So there's two things that we're going to look at for Module 6 review. One of them is implicit differentiation, and the other one is related rates. So for implicit differentiation, what is our goal? Our goal is to take a derivative, and then we're going to separate our dy's and our dx's, and then we're going to solve for dy dx. So if I look at this first one, I need to do product rule because it's first times second. It's variables times variables. So I need to do product rule. Product rule says I have the first times the derivative of the second. So the derivative of y is 1 dy plus the second times the derivative of the first. So the derivative of x squared is 2x dx. So remember, wherever you're taking a derivative, whatever variable you're taking a derivative of, it gets either a dy or a dx. So I've got first times derivative of the second plus the second times the derivative of the first. And we're going to do the same thing on the next one. I'm going to leave the negative out front, and I'm going to group up the 6x and then a y squared. So I have first, which is 6x, times the derivative of the second, which is 2y dy, plus the second, which is y squared, times the derivative of the first, which is going to be 6 dx. And that's going to equal 0 because 14 goes to 0. Okay, so now the calculus part is done. All I've got to do is organize. So I'm going to start organizing by distributing this negative. And I'm also going to organize my 4 terms. So this one is just going to stay in x squared dy. But this one, I'm going to put the number first, and then the x, and then the y. So I have a plus 2xy dx. And then minus 6x, 2y dy. So that's going to become a minus 12 xy dy. Okay. And then we have the last one. I'm distributing this negative, so it's going to go negative. And that gives me a 6y squared dx equals 0. And now we decide what stays on the left and what goes to the right. So this has a dy, it's going to stay. This has a dx, it's going to go. This has a dy, so it stays. This has a dx, so it's going to go. Okay, so these two stay on the left because they have dy's. These two are going to the right because they have dx's. So how do I do that to both sides? I'm not going to have room to write it over here, so I'm just going to write what I'm doing underneath. And you have to understand that I'm doing it to both sides. Okay, so I have a negative 2xy dx. And then a positive 6y squared dx. So that's going over to here as well. I just don't have room to write it that way. So what's left is I've got an x squared dy minus a 12xy dy equals a negative 2xy dx plus a 6y squared dx. Okay. So now I've got my dy's on the left and my dx's on the right. What I would like to do now is find out how to get the dy by itself. So these are not like terms. Your other option is to factor out what's common. So I'm going to factor out a dy. You could factor out an x, but I'm just trying to get dy by itself. So I'm going to factor out a dy. That leaves me with x squared minus 12xy. Okay, so I just factored out the dy, which left me with x squared minus 12xy. On the right side, I'm going to factor out a dx. That's going to leave me with a negative 2xy plus a 6y squared. Okay, and now I'm almost done. How do I get this by itself? I want to get the dy by itself. So how is it connected here? It's connected through multiplication. So I need to divide both sides by x squared minus 12xy. Okay, so now I have dy equals dx times negative 2xy plus 6y squared over x squared minus 12xy. And I can make these parentheses longer to incorporate the whole fraction. So dy dx is almost by itself. What is my last step? I need to divide both sides by dx. So I'm going to divide this by dx, and I'm going to divide this by dx. So I find out that dy dx equals a negative 2xy plus a 6y squared over x squared minus 12xy. And that is your final answer. Ooh. There you go. That is your final answer. So let's try another one. We have this is a plus. Okay, so that's the problem we're starting off with. I need to solve for dy dx. So this is going to be product rule again. So I've got first times the derivative of the second. So the derivative of y cubed is 3y squared dy. Plus the second times the derivative of the first, which is 2 dx. Okay, so we've got first times derivative of the second plus the second times the derivative of the first. Now we do the same thing over here. So I have a first and a second. So plus first times the derivative of the second plus the second times the derivative of the first dx. And that's going to equal 2 dx. And then the 13 goes to 0. Okay, so rewrite first so everything's a little bit clearer. I have a 2 times a 3. So that's going to give me a 6 xy squared dy. This is going to give me a plus 2 y cubed dx. This is going to give me a 3x squared dy, so there really wasn't much cleaning up to do. 6xy dx equals 2 dx. All right, so I want my dy's on the left. I want my dx's on the right. So this dx is already on the right. I don't have to worry about him. But I do have to move this one, and I do have to move this one. So how do I move them? I'm going to subtract 2y cubed dx, and I'm going to subtract 6xy dx from both sides. So now I have a 6xy squared dy. This term went over to the right. This is a 3x squared dy. That term went over to the right. And so what's on the right at this point? I've got a 2dx minus a 2y cubed dx minus a 6xy dx. So that's what's on the right, and I got my dy's on the left. So now what do I do? Since these both have dy's, and since all three of these have dx's, I'm going to factor out a dy and factor out a dx. Okay. Now what do I do? I'm going to divide both sides by 6xy squared. And that gives me dy equals dx times Okay, so what's my last step? My last step is to divide both sides by dx. And there you go. That is implicit differentiation. So what's the other thing that we're looking at? We're looking at related rates. And I'm going to pause for a second so I can bring up a problem. For related rates, we're relating how rates work with one another, which is why it's called related rates. So if I have a particle that is moving along the curve y equals 2x squared plus 4. Okay, so it's moving along a parabola in such a way that the x-coordinate is changing. So that's dx dt. The x-coordinate is changing at a rate of -2 centimeters per second. At what rate is the particle's y-coordinate changing when the particle is at the point when x equals -1? Okay, so what are we going to do first? We've got all this information. We've got a dx dt, so that pretty much tells me to take a derivative. Anytime you hear about rate of change, that means take a derivative. So the derivative of y is dy dt. Remember, with related rates, we incorporate the variable of time. So this is asking, how is my y changing as time changes? Okay, what's the derivative of 2x squared? It is 4x dx dt. So this is telling me how x is changing as time progresses. What about 4? 4 just goes to 0. Okay, I'm trying to find dy dt because I want to know how the y-coordinate is changing. So I have dy dt equals 4 times -1 times -2, which is going to give me -4 times -8 is 8 centimeters per second. Okay, so let's try another one. A stone dropped into a still pond sends out a circular ripple whose radius increases. So there's a rate of change on the radius at a constant rate of 3 feet per second. How rapidly is the area enclosed by the ripple increasing when the radius is 2 feet? So area is pi r squared. Okay? So how rapidly is the area changing, which means we're going to find dA dt. So how is the area changing as time progresses? And now I need to take a derivative here. Remember that pi is a number. It's not a variable, so pi is coming along for the ride. So I drop my 2 out front. Okay. And then I took the derivative of r, so I've got dr dt. So how is this changing? dA dt equals 2 times pi times radius. My radius is 2 feet, that's given to me, and dr dt is 3. So I end up with 12 pi. Okay, let me find another one. All right. We have r squared equals 243 x to the third. So a technical support contracting firm hires people to work from home using their proprietary support scripting system. The more employees they have, the more contracts they can support, and therefore the more revenue they can generate. Suppose that the company's revenue and number of employees is related by r squared equals 243 x cubed. R is the revenue in thousands of dollars. X is the number of employees in hundreds. So if there's no shortage of work to be done, the company currently has 2,700 employees. So we know that X is 2,700, but we're reporting in hundreds. So X needs to be 27. Okay. The company wants to increase their revenue from 2,187,000. So revenue is 2,187,000, but we're reporting in thousands, so it's really 2,187. This is how much I'm making this year. Next year, I want to make 4,374. So revenue next year is going to be 4,374, which is going to turn into just 4,374. Okay? So the question is, well, let's not worry about the question yet. Let's take a derivative and see where we're at. So what is the derivative of r squared? The derivative of r squared is 2r dr dt equals, what is 3 times 243? I don't know. 3 times 243 is 729. X squared dx dt. Okay, so I need an r. I'm trying to find dr dt because I'm trying to figure out how the rate is changing. No, I'm not. I'm looking for dx dt because I'm trying to figure out how many employees need to change. So I need an r, I need a dr dt, I need an x, and I'm going to find dx dt. So do I know what r is? I do. It's 2187. So 2 times 2187 times dr dt. Well, there's an issue there because dr dt I'm not given, but I am given how it changed. Okay, so I can take 4,374 and subtract 2187. And that gives me 2187. Okay, so dr dt is going to be 4374 minus 2187, which gives me 2187. So dr dt is 2187. Okay, then I have equals 729 times, what is my x? My x is 27. Dx dt. Okay, sorry, that's kind of squishy. All right, so I'm going to clean this up first. I've got 2. And it's thinking. I think my calculator just died. Oh my goodness gracious. Okay. So we have, let's do this again, 2 times 2187 times 2187 gives me 956, 593, 8. Equals 729 times 27 squared gives me 531, 441. Dx dt. Okay, so how do I get dx dt by itself? I'm going to divide both sides by 531, 441. So that gives me 18. But we have to remember that we're working in hundreds. So really and truly, how many employees do I need to hire? I need to hire 1,800 employees in order for this to work. Okay? So if you want revenue, remember that revenue is X times P of X. Okay, if that's not given to you, you better remember that. And then you can figure it out from there, okay, if you're given a revenue function. But this is it for Module 6.